Good morning to one and all. So today we will discuss a topic that's the properties of a good average. So previous classes we have discussed about the averages. So we have discussed about and arithmetic mean and geometric mean and harmonic mean. Okay. So when we are estimating this kind of averages, uh, which average is a good one? So among three averages, basically, if you take into account that is the arithmetic mean, geometric mean, and harmonic mean. But when you are applying in a particular research or in some other aspects of your interest, so which average is a good one? So that is the question arises. So before knowing that, we need to understand which average is the best. Nothing but on the properties of there. So we'll come to know that which average is a good one. So here, each and every average have their own properties and their own characteristics. But wherever it requires, we need to apply the particular averages in the research orientation as well as in the statistical methods and other aspects. So that we'll come to know that what are the properties of good average. For example, when you consider that arithmetic means a good average, for example, if you think that, but what are the properties of the arithmetic averages? Then we need to know. So here we need to know that what are the properties of good average. So in the introduction part, as we have studied that about that Crux and Cowden, who has given the definition to the statistics also. So in his words, an average value is a single value within the range of data. For example, if you take into account, if I ask the question to you that, so find out the average or find out any average value of a given data set. So whatever you are going to get some value, that value is average when you're estimating the average. So that an average value is a single value within the range of the data. For example, if I give a question to you that what is the average of your marks and your friend marks? For example, if your marks is 10, your friend marks is 20. What is average marks? Generally, you may calculate the sum of the two marks, nothing but two members marks divided by 2. The sum of x by n. So 10 plus 20, 30, 30 by 2, 15. So the 15 value is within the range of the data only, within the range of the data. It cannot beyond that. It cannot be beyond the data set. Is it right? So 10 and 20. The average value is within the range of the data. Is it clear? Hello, dear students.
Yes, sir.
Yeah. So an average value is a single value within the range of the data that is it to represent all the values in the series. So whatever the data, the average is there, that should be used to represent. When we are going to say that the 15 is a represent of the two members marks, because 15, the average marks of the two students is 15. The 15 number that is used to represent the two member, that's called all values in a series. For example, if you take a series, there are a number of variable. For example, if in your class you may have that 80 members, for example. So if I calculate the average, the in internal marks, for example, 12 marks, the 12 marks that can be represent all the values in the series. Nothing but series in the sense uh, all the students marks. Okay. Then the value of average lies between maximum and minimum values also. For example, if you take in your class, for example, if you take class marks, for example, sorry, if you take marks in a particular class, for example, some people may get out of 20, out of 15, some people may get 15, some people may get 1 also, some people might get 0 also. But whatever you are going to get the average value, that value average lies between that maximum and minimum of the series. That is why it is also called measure of central tendency. Measure of central tendency. For example, if you take then central tendencies, there is a, for example, if you get any average value, that should be in the that value lies between maximum and minimum. Maximum and minimum. For example, if you take into account the cricket, for example, the IPL is going on, For example, if you take the Kohli, for example, if you take, there is a good batsman. For example, if he score in a first match, he may score 10 runs. In the second match, he may score 50. So what is the average of the batsman runs? 50 plus 10, 60 by 2, 30. The 30, the value, that is the average value, lies between maximum minimum. So within the Virat Kohli, the minimum is 10, maximum is 50. Yeah, two IPLs. Okay, in first match he scored 10 run. The second match he scored 50. So the minimum is 10, maximum is 50. For example, if you take during the IPL season, for first two match to last match, for example, the lowest is 10, he maybe highest is 110 or 120 or 95. For example, I'm saying. So whatever you are going to calculate average value, that value should be, or that value should lies between maximum and minimum. Okay, in that case, that is a reason it is also called measure of central tendency, or MCT. MCT, measures of central tendency. Central tendency is nothing but, so it is an average, it is very close to center point. It is close to center point. That is called the average is called measure of central tendency. Is it clear now? Okay, then for example, what are the properties are there? For example, when we are talking about that properties of good average, so there are some other important properties are there which are a good average should satisfy. For example, on the basis of some characteristics only, we may say that is a good person. For example, if somebody will ask that who is a good person in your class, but on the basis of some characteristics, we can define that the person is a good person. At the same time, when somebody will ask that which is a good average, so if the arithmetic man has a good characteristics, we may say that arithmetic mean is a good average. If the geometric mean has a good characteristics, we can say that the geometry is a good average. If the harmonic mean has a good characteristics, then we can say that it is a good average. So meanwhile, like that, then there are some following important properties which is a good average. Okay. For example, how we can define that whether it is a good average or not. So we cannot say it is bad average, but we can say that good average or not. So here the first point, the average should be easy to understand by layman. For example, if you take when with unknown person, we can say layman is nothing unknown person. The average should be easy to understand by the layman also. So without knowing person, for example, if I am a illiterate person, for example, if you take into account, so if I calculate, if I understood, for example, my understood level is also very important. For example, if each and everyone understand that particular concept or that particular average, there should be a good average. Okay, so it should be easy to understand by the layman. The second property, it should be simple to compute. It should be simple to compute. For example, when you take into account in the statistical part, in the calculation part, so when you are estimating the averages, which one is good, which one is simple? So if you take into arithmetic mean is simple. For example, when you compare with that geometric mean and harmonic mean, arithmetic mean is simple. So whether which 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 average is simple to compute, that average should be called good average. For example, you can think about which one is simple. For example, for me, average arithmetic is simple. For you, it may be geometry is simple. Sometimes it differ from person to person. Okay. So then third property, it should be based on the all the items in series and given them equal weights. For example, see first part, it should be based on the all the items. For example, when you are estimating the average, we are going to take all the items. We will not ignore any item in the series. For example, if you take median, so median we can ignore some values when you are estimating the median. But when it comes to the average should be based on all the items in a series with respect to arithmetic mean, geometric mean, harmonic mean. Okay, so it should be based on the all the items in the particular given series and gives them equal weights. For example, see, sometimes we may give the equal weights. For example, which average gives equal weight to all the series, all the data in a particular series. That is a good average. Then fourth property, it should not be affected by extreme values. It should not be affected by extreme values. What is extreme values? Can anybody can say that? Hello, dear students. Can anybody can say that what does it mean by extreme values? Earlier I told you that when I discussed about arithmetic mean. Extreme values. Can anybody say? Hello? Are you there? See here, the extreme value is nothing but the arithmetic mean is affected by extreme values. I told you that arithmetic mean is affected by extreme values. Why? For example, if you take a data, for example, if you take the runs of the particular batsman, for example, if you take Kohli, okay, in the particular match, in a particular first match, he may has done, he may scored 50. The second match, he may scored 0, nothing but duck out. The third match, he may scored 150. The third match, he may scored 150. So what is the average of 3 IPL match? See, that is a 150 and 50 and in the second match 0. Okay, then 50. Just a minute. 50 plus in the second match 0 and third match 150. So what is the total value? 200. Then 200 by 3 matches, the average score is of particular batsman is 66.6. But when it comes to the uh, value of 0, which is very away from that average value, do you think that? So somebody will say that we can say the average value of particular batsman is 66. But some people think that average is nothing but, so in every match he has done an average 66. But when you take into account the particular data, in the second match, he has duck out nothing but 0. The 0 is very away from 66.6. So that is the extreme value. And also the 66.66 are so very away from 150. 150. So the here the 0 and 150 are the extreme values, not 50, because the 50 is very close to the 66.6. Okay, here in the extreme values are 0 and 150. Okay, this is a very important question. So which will ask in the for the PG entrance or other computer exams. For example, if you take PG, Central University entrance exam, as well as the UGC NET and SET, another JL or DL also, the question will be asked. This kind of question. What is meant by extreme values? Which average is affected by extreme values? The arithmetic mean is affected by extreme values. You can remember. Then it should be rigidly defined. For example, when you are calculating average, what is average? It should be strictly defined. What it is? What it is? What is mean by arithmetic mean? What is mean by geometric mean? What is mean by harmonic mean? That should be strictly. We should be defined. And that sixth property of that good average is its value are not greatly affected by sampling fluctuations. For example, if you take whatever we are calculating that averages, when we have that data set, the data set should be in the sampling fluctuation. For example, when you are taking 3 IPL matches, for example, if you take when we are taking first match and third match and 10th match, we should not take like this. Okay, so we need to take in a systematic manner. Then we will compute or we will calculate the averages. So its values are not greatly affected by sampling fluctuations. For example, if you take also, for example, sometimes they will take in the randomly. For example, the IPL match. For example, in a particular a what is called match, what is called Mumbai Indians, some other what is called group, or we can say that in that case we will take first match, third match, and fifth match, and seventh match, and ninth match, like that. So in the odd number, or sometimes we will take the even number also, for example, during the particular season. So if you take such kind of data also, the data should not greatly affected by sampling fluctuations. Where we are taking sample, for example, in particular 10 matches, if you take the sample of scores, first match and third match and fifth match and seventh match, these are the samples. First, third, and seventh, fifth scores on match fifth scores. So that are the sampling. So when you are taking such kind of data, when you're calculating averages, the average value should not or not greatly affected by sampling fluctuations. So that is the main property. And seventh property, it should be capable of further algebraic treatment. For example, if you take in algebraic treatment in the statistics, whatever we are going to calculate averages, it should be capable of further algebraic treatment. For example, if whenever you are interpreting the results also, though that should be very accurate, it should not be biased also. So that is a one kind of thing which is related to the algebraic treatment. And the eighth property, not affected by
Sir,
skewness. Yes, please.
sorry for the interruption, sir. I didn't get the seventh point, sir.
Yeah, see, it should be capable of further algebraic treatment. For example, if you take into account when you are estimating the averages, it should be capable of further algebraic treatment. For example, if you take, it should be take as a what is called a base, like that. For example, if you take into account when you are estimating of in a particular, for example, if you collect the information in particular area of in Hyderabad, for example, if you take a software company, so what is the average of salary in particular working company? Okay, so if you take that average as a base for the next study, okay, so that should be very capable. That should be very base to the further research, because we can quote that. See, in earlier in the last year, the annual average of the salary in particular in a particular company is 40,000 per month, like that. So when you are estimating that statistical tools and statistical research, when you are doing research, whatever we are going to get the average, that should be very capable of the further algebraic treatment. Nothing but here the treatment, nothing but, so when you are estimating the values in the further next by step, like that, so it should be very capable. I think I hope you understood, or else I will give a very the eighth point, not affected by skewness. So whatever we are estimating the average, that should not be affected by skewness. What is the skewness here? When you are doing when you are the data is there, when you are putting in a particular graph that is in normal distribution, when the right side and left side, for example, earlier I told that normal distribution is nothing but bell-shaped curve. Bell-shaped curve. So when there is a distribution is the right side, it may be called positive distribution. When the distribution is in the left side, more, that is the negative skew distribution. So here, when the data is in the normal distribution, we will get the average is very close to the particular data sets. For example, if you take a data which is a positive skewed, sometimes negative skewed also. Okay, so that should not be affected by skewness. For example, if you are estimating the average should not be affected by skewness. So which is very close to that. I told you that the difference is extreme values, not affected by skewness. For example, if you take 0, 50, and 150. See, for example, when you get to the average is 66, so which is away from 66, so which is away from the 0, and which is very away from that 150. The gap between that, see, 0 and 150. Mean in the middle, it may be 66. The 66 is very close to 50 only, but it not very close to the 0 and very not close to the 150. I think you more understood. Have you got the point or not?
Yes, sir.
Yeah. Okay. Then ninth property, possible to find control tendency for open-end classes. For example, if you take into account when we are calculating that averages by using that continuous series, you can say open-end classes, right? In the continuous series, we have the 10 to 20, 20 to 30, 30 to 40 like this. So, for example, if you take, we can able to find out average when the tendency is open classes. Nothing but when the data is in the open-end classes, nothing but in the continuous series. For example, if you take 0 to 10, it may be 0, it may be 10. In the middle also it may be have. In that case, we will find out the averages also. So possible to find control tendency for open-end class intervals. So in many distributions, ends are open. Sometimes if you take into account the research, we may say that if you calculate the income of the particular company, for example, I told you that software company. For example, if you take a company, for example, if you take any X company, for example, software company, you may get you are going to get some information about their salaries. Okay, so salary may be 0 to 10,000 in the first class, the second class 10,000 to 20, 20 to 30, 30 to 40, 40 to 50. Then after that, you may get 50 and above. Nothing but 50,000 and above. Some people may get 50,000 and some people may get more than 50, which we will write 50 above like that. 50,000 and above. That is the open-end classes. In many distribution, ends are open. So a good average is one which can be calculated even in an n class intervals. For example, see when we have that open-end classes, when you are going to estimate the average, that is also good average. That is also good average. Is it clear now? So on the base of these properties, we may able to know that which average is a good average. So you may think that which average is good one as per your understanding. Which average has a good the characteristics of this 9 characteristics. Some people, some have may not have the 9 characteristics. Some may have 5, 6, 7. Which character, which average the highest characteristics? It may be called as a good average. Okay. So which average is a good one when you are? Can anybody say that? Hello?
We didn't get you, sir.
So you learned about arithmetic mean, geometry mean, and harmonic mean. Which average among these three? Which average has a good properties? Nothing but more properties. Then if the arithmetic mean has a more properties, nothing but this more proper, nothing but they have the good characteristics. This properties we may call as it's a good average. For example, if you think that harmonic mean has a good characteristics of this 9 among this 9, you may call as a harmonic means a good characteristics. Okay, so among these three, which one has a this characteristics, this 9 characteristics? Okay, you may think that you will get it answer. So thank you. Thank you, Vanadal. If you like this video, you can please share and subscribe to get more videos which are related to the statistics and econometrics. I will keep on uploading that some videos related to statistics and econometrics in the YouTube channel. Okay, if you like it, if you like this class or if you like this video, you can share and subscribe. Okay.